So revenue we are going to talk about as R of X. That's the notation you can use for it. And it is how much X items brings in, like how much money it brings in. And this would be when you sell the item. This is not including expenses going out. So this is just when you sell the item before you consider your expenses. So you would say your revenue would be X items multiplied by the price of the item. The cost would be C of X. And this is how much it costs to make X items. Profit is P of X, and that is how much money you make. And this would be after the expenses. And so the equation that we get from this is we say that the profit is the revenue minus the cost. Okay, so the maximum profit is going to occur where the derivative of the profit equals 0. Which makes sense, right? If you had a curve and you were finding the derivative of that curve, where the derivative equals 0 would be that maximum, right? We could look at minimum profit, but we'd actually, and that's a good point, we'd want to consider, we'd think about like our sign chart, and if the number we were looking at, if it showed that it was a maximum or a minimum. So we're going to be careful to make sure that this 0 is in fact the maximum profit, not the minimum profit, because that would be a bad mistake to make if you're giving someone advice, right? You want to be careful, all right? The other place that you can look for the maximum profit would just be the derivative of the revenue minus the derivative of the cost. And really this is just using like a property of derivatives. Kind of, if you guys remember we talked about like the properties of limits way back when. We said that the profit equation was just defined as the revenue minus the cost. So if I'm saying the derivative of the profit equals 0, then we could say revenue minus cost. You just take the derivative of each of those and subtract them. So properties of derivatives would work kind of the same way. If this is what you get after you take the difference of these two, then the difference of those two would work as well. Another way to say it is you could look where the derivative of the revenue is exactly the same as the derivative of the cost. So any one of these will work. When I made my answer key, I did every single one of them, just taking the derivative of the profit and making it equal 0. That's what I did. So it's kind of up to you how you choose to do it. All right, and then last, this is completely unrelated to the business questions. This is the one that has to do with the science questions when we're talking about position versus velocity versus acceleration. We want to make sure we understand the difference between the distance of a particle and the displacement of a particle. And it could be a particle or it could be something else. So the distance is defined as the total amount that was traveled. So distance is total amount traveled. And here you're going to think of like an odometer. So like if you're going on a trip, it tracks your miles as you go to the place you're going and as you're coming back. It tracks it both directions. It doesn't matter where you're going. It's just tracking how far you're driving. So direction doesn't matter. You're just adding all those numbers. And then the displacement is how far you get from the starting point. And to find the displacement, we typically do the end value minus the start value, and that tells us how far we are from the starting point. So two different things, distance versus displacement. And the reason we're specifying those carefully is because when you did problems like this back in Math 3, where it was like the pumpkin was launched into the air, how far did the pumpkin go? In all those problems, they said you were finding a distance, but you weren't. You were finding a displacement. Right? It just didn't really matter. The wording didn't matter because your pumpkin wasn't moving back and forth. It was just moving one direction, and so the wording didn't make a difference. In this case, we have things that are moving back and forth. We have velocities that are positive and negative, and so our particles are moving not just one direction, and that's why now the difference between those two words makes an important difference in the problem. Does that make sense? Okay. So here, when we find the distance, it's going to be very important that you split up your interval with the velocity, and we are going to know how to split the interval by looking at where the velocity equals 0. So we can see when the velocity is positive versus when it's negative, and that will tell us when it's moving one direction versus moving another direction. And those places where the velocity is 0 will help us figure out how to break up our interval so we can see how far it's moving each time. Okay, so that's going to be really important to split that up. All right, so here it says a manufacturer can sell X items a week for a revenue of 200X minus 0.01 X squared cents, and it costs 50X plus 20,000 cents to make X items. Is there a profitable number of items to make each week? If so, find what it is. So we are going to say P of X equals the revenue minus the cost. So P of X would equal 200X minus 0.01 X squared. And then we are going to subtract off the C of X value, and you just have to make sure you put that C of X value in parentheses. Do you guys remember last unit, so if we had an equation and we wanted to find the maximum or the minimum of the equation, what did we do? We found the derivative, right? And when, is that what you said? What did you say? Yeah, critical points. So find the derivative first, and where do you find the critical points? Yeah, it's where the derivative equals 0, right? You solve the, yeah, you had it exactly right. So that's what we need to do if we want to find our maximum or minimum values, is we need to find those critical points. And if they give us endpoints in a problem, we would look at the endpoints as well. And here they don't give us any endpoints to consider, so we're just going to look for those critical points. So the next thing we need to do is find the derivative. And what would the derivative be for the profit equation? 0 to x, right? Plus 150. And that's it. So now we're going to take that and set it equal to 0. So negative 0.02x equals negative 150. And I can divide that decimal over, and what do I get as my value for x? Yeah, 7,500. And like Miles said earlier, we definitely do want to make sure that what we just found, because the derivative can be 0 at a minimum or a maximum, and we want to make sure we're finding the maximum, not the minimum. That would be really unfortunate. So we can go ahead and make a sign chart here. I've got 7,500. And so we're going to take the derivative and plug a number in that's less than 7,500 and plug a number in that's more than 7,500 and just verify that this is in fact a maximum, not a minimum. So what happens if you plug in something slightly smaller than 7,500 or 0? It's positive, yeah. And then if you plug in something bigger than 7,500, it becomes negative. So what does that tell us about this? Increase to decreasing, this really is a maximum. So that means we did find the right number. Right? So we're going to say the most profitable number of items to make is 7,500 items. And one of the things that that I'm pretty big on is if you are looking at a problem that's a real world situation like this, if the problem is a story problem, then we need a story answer. So your answer should be written in sentences, complete sentences, punctuation, capitals, all that stuff, yeah. And the reason for that is I have found that a lot of students can do math but can't interpret their answer. Like, don't know what their answer means. So we want to make sure we always know what our answers mean. So here we're going to say the most profitable number of items is 7,500. Yeah. Yeah, let's do the whole thing. Profitable number of items to make each week. All right, and then the question doesn't ask it, but I do want us to go back and find the largest profit. So how would we figure out what the largest profit is? Yeah, plug in 7,500, and where do we plug it in? Yeah, and your original, you can plug it in right here if you want. You can plug it in right here. You could plug it in right here. I'd probably put it right here just because that's the most simplified version that we had of the original equation. So now I'm going to say P of 7,500. When I plug it in, what do you get when you plug it in? 542, 500. And what were the units from the problem? Cents, right? Most of us are not going to talk about profit in terms of cents. Yeah, you thought. So what should we actually do to that answer to make it like a reasonable unit? Yeah. Divide it by 100 cents to see how many dollars it is. So how many dollars would that end up being?
That's still bank.
I mean that's still money. I'd be okay with that. Per week. That's each week. $5,000 per week.
Yeah, that's pretty good.
That's pretty significant. I could make $5,000 per week and be fine.
$500K a week though,
That's true. If that had been 1,000 per week, that'd be kind of awesome. All right. Go ahead and turn to the next page. All right. We're going to do the same thing again. So it says, given that your revenue is 10x and your cost is this other thing I don't want to read, where X represents thousands of units, is there a production level that maximizes profit, and what is it? So we're going to say the profit is the revenue minus the cost. And then I'm going to go ahead and simplify this. You guys are so good at talking the entire time you take notes. She said sarcastically.
I've been practicing it for 13 years. Since kindergarten, man. We don't. Working hard.
Before you pass the test. Minus 5.
So there is our simplified profit equation. So what do we have to do to look for the maximum profit? Take the derivative. And then what do we do with the derivative? Set it equal to 0. And when you guys look at this problem, what should you automatically be thinking? Factor or quadratic formula. And spoiler alert, this one does not factor. So we have to do the quadratic formula. B squared minus 4 AC. All right, so that gives me negative 12 plus or minus something over negative 6.
You sure?
12 squared minus 4. I got 84 also. Okay. All right. Go ahead and plug those in and see what we get. On the AP exam, they're always going to ask you to round to 3 decimal places. Apparently that's the thing. So a lot of calculus teachers ask you to round to 3 decimal places always, just to get used to that. So we're gonna do that for the most part. So what answers are you guys getting? 3.52. What was the next two numbers?
7.5.
It was 5.257. And then there's an 8, so we're going to do 5.28. Round it up. All right. How about the next one?
0.47.
All right, so there's our two numbers. Should we just assume that both of those are maximums and write both of them? This question has 2 answers. No, what should we do? Sign chart. We got a C.
See, I'm there.
So go ahead and work on your sign chart. Figure out where it's positive, where it's negative. You are taking values and plugging them in right here. This is the derivative.
But you plug it back into the derivative, right?
Plug it back into the derivative.
So the first one is negative.
The first one is negative. And then positive? Are you guessing or did you?
It's negative, positive, negative.
Negative, positive, negative. Marvelous. Okay. So which one of these is going to help us to maximize profit? 3.528. If you were the arch nemesis of this business person and you wanted to not help them do well in their business, what would you tell them? You would tell them the other one. You'd help them minimize their profit. All right. So we're going to say now the units of the production level was thousands, right? So how should we write this answer?
3,500.
The max production level, right? We're going to write a sentence. The max production level is... I wrote that weird. The production level that maximized profit is... And we can go ahead and say... Or you could just multiply it by 1,000 and not put... You can do whichever one you want. You can say 3,528 units, or you can say 3.528 thousand units. It's up to you. I'll let you choose. You have the power to choose how you write this answer. Do you feel independent now? Having the power to choose? All right.
So if you weren't writing down,
If you did not write 1,000 units and you put 3.528, you'd be wrong.
no, if you put 3,528,
You should put the word units. Yeah. Yeah.
Wait, so didn't you say you wanted to find it the last time?
It's just asking you what the production level is.
Yeah, but last time you had it. Never mind. It
Yeah.
doesn't matter.
I just want to make sure you know how to go back and plug it in if you needed to, and we did that last time. Okay, so these ones are the problems that you hopefully are going to be like, yeah, I could do that. This is kind of, we've hit these already, but we're going to hit them again. So it says the particle moves according to this function. This is the position function. This is where it starts. This is how, like, oh, it moved left, oh, it moved right. We're not saying how fast it moved or if it was increasing or speeding up or whatever. We're just saying this is where it is. So if we want to find the velocity, how do we do that? Yeah, velocity is the first derivative of the position. So that would be 3t squared minus 18t plus 15. And if we want to know the velocity after 3 seconds, what do we have to do? Plug in 3. And what do you guys get when you plug in 3? Are you texting, James, and you're figuring it out by texting someone else to ask them? They have 12 feet per second. I think it would be faster to just be like, yo, what answer did you get across the room, then text someone and ask them across the room like what answer they got. So you could then yell it out. You know what I'm saying?
Brandon, did you see the little buttons on the dots?
Yeah.
Yeah.
All right, when is the particle at rest? What equation do we have to look at to know when the particle is at rest? Yeah, no, that's exactly right. So the particle would be at rest when we have a horizontal tangent, which would actually mean what? Like, what are we? The derivative equals 0. Yeah, we're going to look for where the derivative equals 0. So we're going to look for where the velocity is 0, and that's going to be 3t squared minus 18t plus 15 equals 0. And when you look at that, what should you automatically think? You got to factor it. And this one is not too bad to factor, actually. Take out the 3 first. Yep, you got a GCF. So we're looking for two numbers that would multiply to 5 and add to negative 6. Yeah. So t minus 5, t minus 1. So what are the two times that we have? 5. Yeah, and let's go ahead, while you guys are catching up, let's go ahead and write sentences for these, because we got to make sure that we're answering these in full sentences. So the velocity after 3 seconds is... My hand literally just cramped up for writing 2 sentences. That's what it's like when you're a math teacher. I know, but I got to take like more breaks as I was writing numbers, you know? Could not. Oh my gosh, too much writing. And then writing.
Would it be after those seconds or during those times?
At. Thank you. All right, so they want us to check and see when the particle is moving in the positive direction. So what do we do there? We want to see where the derivative is positive, and we want to see where it's negative, right? Right. So the velocity, we want to see where the velocity is positive, where it's negative. And we know that the velocity is going to switch from positive to negative after those times where it's at rest, right? It's either going to be in a negative direction, come to rest, and then go in a positive direction, or from a positive direction, be at rest, and then go into the negative direction. So we're going to draw a sign chart to figure out which way it's moving. Yep, positive. And then what do we get next? Negative. Are you guessing?
No, we plug these dirty
Okay.
different pattern.
And then positive. So the particle is moving Yeah, please don't say your answer is 0, 1 union 5 to infinity. That makes no sense. They're like, what is the particle in the positive direction? Oh, 0, 1, 5 to infinity. All right, yeah, that makes sense. Mathematically, you can write those numbers, but in a context, it does not make sense to write that. And then if we want to find the total distance traveled during the first 8 seconds, so we're not talking about displacement, we're not saying the end point minus the start point, we're saying all of the movement, the positive direction and the negative direction. How do we find all that movement? So we are going to look at the position when you get started, and then we're going to look at the position that you get to after 1 second, so we're going to count that positive distance right there. And then we're going to look at the position at 5 seconds, and we're going to take that negative distance, and we're going to add that. And then we're going to look at how far you travel in those last 3 seconds and see how far we need to add for that. Yep, we plug it into the original. I called dibs on the first one. I already got it. And then I got it really fast.
That's what's in the original page, right?
Yep.
So the x cubed was that one?
Yep. So when you plug in 1, you get 17. Anyone get 5 yet?
No, I gave up on that because I messed up and I didn't
Negative 15. And then how about 8? 60, 66. All right. So from 0 seconds to 1 second, how far did it travel? 7, right? From 7 to negative 15, how far is that? Yeah, and we're just going to say 32 since we're talking the distance. We just want to know that, like, the absolute value of how far it went. From negative 15 to 66, how far is that? 81. So now for us to look at the total distance traveled, we just need to add those up. Yep, 120.
That would be in feet.
What answer would we get if they asked us about the displacement after 8 seconds?
You get 81 plus 6.
Yeah, you would say 66 minus 10 is 56. So the displacement would have only been 56 feet. They went forward, backwards, forward.